Thanks, Bob. All right, so hello, everyone. My name is Michael Scovetta. I lead a team focused on open source security at Microsoft. This means that we build tools, we analyze individual open source projects, and we advocate for safe practices around open source. Open source is core. It's an essential part of practically all modern technology. But for the most part, it's created by volunteers who do what they do out of, passion and interest. For every Kubernetes of the world, there are 1,000 projects like the one on the bottom here, where it's maintained by a single person. Most people don't know who they are or what the component even is. But those components down there can oftentimes be just as essential to your business as the Kubernetes of the world. So a quick legal disclaimer. This talk and all the slides are for general information purposes. They're not intended to constitute legal or professional advice, should not be relied on or treated as a substitute for specific advice. Open source can be a little bit scary, and for a few different reasons. First, there's a lot of it available. Nearly 3.2 million packages available across NPM, PyPy, Maven, and the other package managers. And you can see from the line, that this is, it's doubling every 3 years or so. The numbers are only going up, and they're going to continue to go up. And there were a lot of vulnerabilities. Close to actually a little over 18,000 CVEs last year, and we're probably going to go over that this year. And many more vulnerabilities that aren't disclosed as part of the CVE process. So if I were to guess, I would say CVEs cover about a third to maybe a quarter to a third of all vulnerabilities out there that are publicly known. Now, to be fair, CVEs cover commercial software as well as open source. So, but open source contributes to a big part of this number. And it's also super complex. So the graph here is a rendering of the NPM ecosystem. Each point is a package. Each line is a dependency between two packages. So when you, what it's showing is that the NPM ecosystem in particular is extremely interconnected. So if you use a package like Mocha, you bring in the size of this graph of packages and their dependence and the dependence of the dependence is about 91 packages. If you use React scripts, it's close to 2,000. This isn't confined to NPM. If you use Rails, you get 38 packages. The important thing here, though, is that in this kind of graph, if you were including, Chokidar on the left, but there was a vulnerability in isNumber all the way on the right, that could just as easily impact your final product, your final application, as one at the top level. But you or your engineers didn't include isNumber; they just included Chokidar. So in some ways, this dependency, this transitive dependency graph, makes things complicated and hard to reason about unless you're taking deliberate steps to understand this. So there have been open source security things have been in the news a lot, starting in about 2014 with Heartbleed, and then just kind of going from there. I'm not going to read all of these. The point, though, is that these are not, esoteric, trivia for folks just in the industry. These are hitting the news because these are impacting real businesses. Credentials are being stolen, packages are being compromised. The dependency confusion attack that went public last month. I'm going to talk a little bit about that later. But these are happening regularly, and it's changing the conversation and making it an executive kind of board level discussion in a lot of places. I suspect this will continue, and that there will be continued kind of major attacks, complete with, websites and logos, until things really turn around. So yeah, open source, it can be a little bit scary because at the end of the day, your company is responsible for everything that you ship, including all of the open source and all of the dependencies of that open source. Attacker doesn't care who wrote a piece of software. They're gonna generally go for the easiest way in. Your customers aren't going to care either if you have to notify them, of a breach or something. So the real question is, how can enterprise manage this risk? How can they understand it? What can they do about it? And there's kind of a minimum bar that I think makes sense. And it's really simple. First, you have to understand what open source you're using. Second, you have to make sure that the open source you're using is kind of free of vulnerabilities. And the third part of this is you need to be able to respond when they do have vulnerabilities, because it is inevitable. It is a fact of life. You can't really avoid that. So for the first step, the key here is to build is to have an accurate inventory of the open source in use. The key here, though, is that word automated. You can't do this by hand. At Microsoft, we use hundreds of thousands of pieces of open source. And what we found was that the automation is essential, both from a engineering productivity perspective, because it takes a really long time for engineers to do that, to identify those packages manually. And people are people, and people make mistakes. And what you need is you need that inventory to be accurate. What we do, and different organizations can have different approaches to achieving this, but the way that we do it is when products and services get built, their source code, other artifacts get analyzed, and you come out with a list of components. So there are tools that will parse manifest files and things like that to say, haha, I see Chokidar in this, is being used in this application, and Chokidar's entire transitive graph as well. And it basically just stuffs that into a database. This is, as this became more automated and we covered more systems, we realized how much open source we were actually using. The nice thing about having this database available is it makes response so much easier. When a critical vulnerability is found in component foo, in the past, we had to ask lots of engineering teams, hey, is anybody using foo? And that was just extremely painful and error prone and just kind of an awful experience. So now it is a database lookup and automated notifications to those teams. So now we have a database of the inventory of open source used, but we don't know if it's secure or not. So we and I think any organization needs to have some strategy for ensuring that the open source that they're using doesn't contain vulnerabilities. You could do this in a bunch of different ways. You could just watch the news and wait for really big ones to pop. That's not a great idea, but I guess you could do that. You could include CVE checks. A lot of the commercial tools and open source ones in this space tend to include kind of basic CVE checks, which is fine, and I would say probably the absolute min bar that you should have. You could include commercial vulnerability databases, and you could even add your own static analysis tooling to look for new vulnerabilities. But there's one level higher than that, which is actually rolling up your sleeves and examining a component, which can mean code review in a lot of cases, can mean better, more targeted tooling. And what we believe is that having all components go through a certain level of rigor and then high-risk components go through an even greater level of rigor, is the way to really minimize your risk here. So these in-depth security reviews, this is a core part of what my team does. They are expensive. They are, in some ways, painful to do, but we think it's important. So what does this really mean? We'll look for things like project health. We'll look for secure configuration settings. So as an example there, Elasticsearch, one of the guidance that we would probably obviously give out is don't expose Elasticsearch to the internet directly. We'll look for public vulnerabilities in places that aren't CVEs. We will run our own tools, static and dynamic. We will document this stuff all up and provide it to engineering teams that are interested in using a component, particularly when it's a core part of their service. And then when vulnerabilities do happen, they really fall into two categories. There are the easy ones and the hard ones. Thankfully, most of them are the easy ones. And what I mean by this is a vulnerability is found in component foo. The maintainers of foo, release a new version, a CVE is announced, and because we have this inventory, we're always checking against new vulnerabilities as they come out. Engineers that are using foo just get an automated notification, or in the best scenario, they just get a pull request with the version update. So I think around 99% or so of vulnerabilities go through this process, which is great. And then there were the hard ones, the ones that really require cross-company collaboration and coordination. And maybe it's a project that's really important and essential, but doesn't have a fix. Maybe it's something that we found that we need to coordinate disclosure on. We have a MSRC, at Microsoft, handles that coordination and response. And these are important. You can't forget about the hard ones. You do have to take care of them when they occur. So we've handled this kind of minimum bar. So you have an inventory. You are pretty sure that the inventory that you're using is secure, or at least you know about the vulnerabilities. And then you respond when they're not. So are we done? Well, no. We need to be thinking about a lot of other things. So there are, just do that. That slide doesn't look nice. There are a lot of other areas where risk can come in that really don't fall into the previous categories. These are just some of them. There's probably a dozen or more additional ones, and I'm not going to go through each of these, but this kind of gives just a map of places where risk can come in, and that there aren't great solid mitigations in place cross industry. Everybody is trying to figure this out on their own. So, as an example, I talked a little bit about project health. Is it still being maintained? Is it just, what's the quote bus factor? Backdoors, like attackers are focusing on open source and inserting, malicious code into them for the purposes of taking over, or somehow messing with the users of that open source. Typo squatting is a big problem, and each of these areas are sufficiently interesting, I think, to account for multiple webinars. We don't have time for that today, but I would refer you to a paper that we wrote as part of the Open Source Security Foundation that looks kind of end to end at all of the threats and risks and scenarios around using and leveraging the open source ecosystem, and where the big problems are, and some suggestions on what can be done about it. You're welcome to the white papers available at the link below. So with the remainder of my time, I'd like to talk about a couple of case studies which I think illustrate some of the risks that may not be obvious, that people tend to be vaguely aware of, but I found that it's helpful to go into a little bit of detail on what these actually look like. So the first one is typo squatting. It is similar to domains, domain typo squatting, where instead of Microsoft, it's like Microsoft.com, except that these are packages instead. So, back about a year ago, attackers published about 725 malicious packages in the Ruby Gems ecosystem. It took 2 months to find them, and these were, the packages were named things like Atlas-client instead of Atlas_client. The purpose of that malware was to steal cryptocurrency, but people publish these packages for all sorts of reasons. Another one hit the Python ecosystem with Python 3-dateutil, which was not the same as dateutil, and other folks using kind of homoglyphs to that they hid a capital an L where there's a 1 and things like that. So we recognize that this became a problem. A while ago, we wrote some internal tooling to find this. As an example, when I did this presentation about a year ago or so, about a year ago, and in preparation for that, we ran this against Django, and literally the very first one that came up turned out to be a typo squatted package. So we got it fixed and we got it removed and everything is good and now it's gone. But these things pop up all the time. Over the past, I think this is about 2 years, the major ones from about 2 years of work here. We found cryptocurrency, we found typo squatting against literally the top 10 most downloaded NPM packages. We found reverse shells. We found data exfiltrating kind of backdoors where they grab configuration and access tokens and send it to Discord. So we want to do a little bit more than just have a service ourselves. So we have a project on GitHub called OSS Gadget, which is our Swiss Army knife collection of interesting tools that we use and we thought would be valuable to the community. So we recently added the typo squatting detection in there, so you can literally from a command line just run this against Django, for instance, and it will generate the list of possible typo squats and queries the registry to see which of those exist. So in this case, there were, five in the Python registry. But to be clear, all 5 of these are legitimate projects. They just happen to be named like Django. So just because something has a similar name, it doesn't mean it's bad, but it is something that should be looked at once in a while. So back in 2019, there was another backdoor. This one in the Bootstrap SaaS project. The way this one worked was you essentially had the part of the backdoor that was kind of evil took a cookie, decoded it, and then executed it. So it was just a classic kind of backdoor. So we took a look at the pattern. We said, hey, this is something that we could probably scan for. So we downloaded every package from Ruby Gems, thinking perhaps the Bootstrap SaaS backdoor was not the only one that the attacker uploaded. So we ran this for a couple hours, and we found 2 more using a very similar pattern. The top one here is the Bootstrap SaaS backdoor, and the one on the bottom is from Ruby Tree, and then there was another one in Simple Captcha 2. So it was nice. So we felt good in the approach that we could that we could find basically similar patterns to known backdoors. We confirmed this by looking at the project page, and what we noticed here was that Ruby tree, for instance, in the Ruby Gems ecosystem, version 1.0.0 was published in December 2017, which matches over here on the left the version published on GitHub, and then 1.0.1 was published in 2019, and it didn't have an associated release on GitHub. So we thought that was curious, and maybe that would be another indicator. So we ran that pattern through everything in Ruby Gems, and we only found the 2 additional ones that we had already found. So we felt pretty good that analysis was complete. And now dependency confusion. So dependency confusion was came from an article by Alex Burson in early February, and here's this isn't a big talk on how it works and how to defend or things like that, but I think there are some interesting aspects here. So as a super high level primer, this is how it works. A package manager client is something that lives on your device. A registry is something like PyPy or NPM. There are internal registries that companies can set up privately, and there are public ones. But generally the way that it works is the client says, hey, do you have foo? And the registry says, yep, here you go. It gives you back the binary or the source code or whatever. On the internal side, it works exactly the same way. But what happens if the same package name exists in both the internal and a public registry, and they are different packages? So the scenario here really is, for years I've been using this internal package called, well, I guess foo, and everything was fine. But there was no discrepancy because foo didn't exist outside. But now someone on the outside figured out that you were using foo internally and published foo outside too. So now there's some ambiguity. What should the package manager client do? Does it prefer internal over public? Does it randomly choose one? Does it error out? Is there a implied ordering there? Unfortunately, every package manager is different, and the steps that you'd need to take in order to mitigate this risk, kind of depends a bit on context and your setup. So fortunately, there are some good resources. GitHub's published a few, we published a few, and there's a lot of thought and discussion in the community on how to really handle this. One of the easiest ways to do this is with scoping scoped namespaces. So on NPM, you publish your internal packages under a scope that's reserved for you, so that no one else can really choose the same name. But there are lots of other strategies as well. What our role in this, as this came up, was to detect dependency confusion. So we had a pretty simple strategy here. We looked for we assembled a list of all internally used packages. So going back to a much earlier slide, having an accurate inventory of the packages used also included internal packages. So we have this giant list, and then we simply watched for new packages as they were published. If the package name is on the list, then send us an alert. And we were particularly interested in packages that were published for the first time externally. So we looked at the package, other packages by the same author, and if anything kind of looked dodgy, then we alerted the package management systems kind of security team. So we reached out to PyPy or NPM or anybody else, and they generally took the packages down. What we weren't quite well, I won't say we weren't ready for it, but we weren't expecting it, was the volume here. So we've been looking, so we generally examine about 2 million packages a month through the system that we built. And since mid-February, we've had over 15,000 packages that were in this case dodgy, that we've been able to get removed from the registry. I just want to be super clear. There are lots of researchers and companies looking for these packages, so I can't claim that we were the very first one to find all 15,000 of these, but when we reported them, they were still active. So that's my disclaimer, as like lots of people are doing this as well. So I want to show you what these actually look like, because I think these are interesting, and they kind of come in 5 flavors or 5 levels of spiciness. And the first one is the most basic. This is clearly a proof of concept. This is done by a security researcher, presumably a security researcher, and this is against NPM projects. So when you install an NPM component, an NPM package, there's a list of scripts that's contained in it, and it's just, after you install, do this thing, or in this case, right before you install it, do this thing. And this thing is run index.js, and index.js, all it does is basically ping the attacker's or security researcher's endpoint here with the package name. So that's okay. I mean, is this an attack? Is this a backdoor? I don't know. I'll give some arguments in a few minutes on why I think this is still bad. But there were about 14,000 of packages had this pattern. I think these came from a handful of different authors, but there was really one author that did the bulk of them. So it was obviously scripting, and they just created packages for, literally thousands of they created literally thousands of packages, and this went across NPM and PyPy. Okay, so stepping up a level of spiciness. This is one that there were, I think, about 1,200 packages, 1,100 packages that did this. So what this one's doing is grabbing the host name, the username, the company name was filled in because I guess this was, when they were attacking, Microsoft, for instance, this said Microsoft, and the package name, and it took all the stuff together and it either posted it to a website in the same way. A lot of these were actually exfiltrated over DNS. So the string here was just it was data dot, some other domain, and then they would just look in the DNS logs for the data. So now this is, well, okay, so username and host name, directory name, these could be moderately sensitive. So I think there's a good argument on here on, like, why do we even care about this? It's just a proof of concept. These are just security researchers. And the reason that I think we should care about this is that, number one, well, they can break software. So, real systems can go down as a result. They can certainly become malicious. So if I were, a real attacker, I would probably start out and publish benign packages as a security researcher and make them super benign so that people kind of ignore them. And then I'm just going to upgrade them to be malicious in the future. And we can't guarantee that just because the package says, oh, I'm just a security researcher, attackers can lie too. And finally, I think the third most important reason is they still exfiltrate some interesting data. Your IP address, I'm not a lawyer, this is not legal advice, but the question about, is an IP address considered, sensitive in any way? I think the answer is probably yes. Host name could leak details. Your local directory could, leak details on your, configuration or, architecture. Local username could leak some stuff, and all this is just going out silently. So we felt like we were like it was the right thing to request that these things be taken down. But those are only the first 2 spicy levels. So now we get into the things that I think there's really no justification for, even if you really squint and try to see this through the eyes of a researcher. Thankfully, there were fewer of these types of packages. So this one is very similar to the first in that it, basically just does first or second. It's similar to the second one because it exfiltrates the current working directory, the host name, and all of your environment variables. So your environment variables are, can contain tokens and, other secrets. Now, it's probably a best practice not to store secrets in environment variables, but we know people do, and therefore this attack is clearly intending to exfiltrate sensitive data. And then we go one step up. This occurred in a few packages that we found. I think only 2. The context here is this was a typo squatting package against a super popular npm package, and what they did was they took the real package and they just copied it, and then they interspersed these lines here kind of randomly within the rest of the source code. So they weren't all bunched up in one section. I guess they were trying to hide. And what it would do, this last line here on the bottom is the thing that does it. It sends your presumably conf.token is some sort of an access token, and they just send it to a Discord channel. So it's clearly intending to exfiltrate data. And then the final one is just where the attacker just says, I just want to be lazy. I don't know what I want. I just want persistent access. So this just opens up a reverse shell for the attacker. So it's, this one's super bad. So as I said, open source can be a little bit scary. The attackers are active in this space, and they are interested, and they are having success. At the same time, I think that there are good reasons to be optimistic. So there's a lot more interest and discussion and movement than there was 5 years ago in this space. Just today, I noticed that GitHub added support for secret scanning within Mai Tai. So I think that's terrific. There have been some good successes in terms of reproducibility and projects like Chaos that focus on project health. The OpenSSF, if you're not familiar with that, I strongly encourage you to take a look. It's a industry group where the entire focus is on, let's all come together to tackle the hard problems around open source security. There are tools from, everywhere from, OWASP, like dependency check, to groups like in toto trying to advance software bill of materials and, validated builds and things like that. GitHub's done a ton of work in this space, and and the countless security researchers that each advance a little part. With every new attack they describe, we advance as an industry in how we understand this and the steps we can take to mitigate risk. So I really do want to thank all of the organizations that have really stepped up here in the past few years. I'm quite optimistic that in the next few years we'll see very meaningful progress toward ensuring that the open source ecosystem is not the weak link, because open source provides a ton of value. It is so core and essential, and it would be a horrible failure if this work reduced the amount of interest and use of open source. We want there to be more open source. We want there to be more better open source, I guess. So the key takeaways from this talk are really, wherever you are, every organization is different, and I can't claim that what works for us would work for you literally. But here are the things that I've kind of taken away. First, if you don't have an accurate inventory of the open source you're using, I think that's probably one that should be very near the top of your list. Automation is essential. If you are doing things with questionnaires or spreadsheets, please consider alternatives. Anecdotally, you should probably expect that a manually attested list of open source is probably off by at least a factor of 10. So you really want that automation, and there are vendors that do this, that can help there. Use high quality vulnerability data sources. Don't assume that CVEs are complete. It's like CVEs are like the absolute min bar, but if you are, especially for kind of your mission critical applications, you probably want a little bit better than CVEs. When vulnerabilities do happen, try just to leverage existing processes. Make it seamless for the engineer. Let engineers just get an alert, upgrade, maybe it's a pull request. If you do need to, coordinate things, across your organization, leverage whatever existing incident response processes you have. This is a journey, so every organization, as I said, starts in a different place. But if you haven't started, start today. It is really important. Not all open source is at the same risk level. So if you can identify the packages that are most important to you, hopefully in a data-driven way, then you can focus more attention on those, because most organizations use an incredibly high volume of open source, and you literally can't do everything to all of them. So even when I mentioned the security reviews that my team does, we focus on the high-risk components, because we can never finish doing all of them. So it's a mixed approach. A general best practice that I found is, if you have a culture or an engineering practice of just keeping open source components up to date regularly, that can mitigate a lot of risk, because generally speaking, the latest stable version of a component is the most secure. There are outliers where that's not the case, but it's probably a good rule of thumb. So you wind up mitigating so much risk just by having that practice, where you don't need to be responding as much. And then finally, kind of this open source security supply chain. This is a very evolving landscape. Things are changing all the time. There are new things that hopefully should be landing in the next year that will, help ensure, provenance and, integrity as open source moves throughout its kind of life cycle. Watch the space and be ready to take advantage of some of these things. So I'll leave a couple of resources here. Some of these are tools that we've written that either that we think can provide value within an open source context. The Open Source Security Foundation, there were links there. I highly recommend taking a look, and if you're interested, joining. We have some tools, and the top link is to the white paper that I mentioned. I would be super happy to take any questions, and I will make sure that the slides are available. So, thank you.
Thank you, Michael. Let me just see here if we have any open questions. So there is one regarding, it goes like this: from the Microsoft managed Azure Databricks, that is, how are you controlling the types of packages being installed?
That's a great question. I don't know the answer to that. I would refer to the Azure team that does that integration. I think generally speaking, a lot of whenever there's a kind of an extension model, so this would go true for browser extensions or Databricks modules. There's always you have a microcosm of the larger open source security ecosystem risks there, and a lot of it is the answer I would guess is very context dependent in terms of what kind of sandboxing is available and the capabilities of the extensions and things like that. But I don't know specifically about that.
Sounds good. And the next one is, we're a small shop, and the effort that you're saying is vital for creating a secure open source software environment far exceeds our abilities, and yet we still need OSS to build out our critical applications. Are there any reliable third-party entities that can be hired to verify OSS puppies?
That's a great question. So I can't endorse any specific third parties. There are, I mean, if you just web search, open source security, you'll very easily find the top 3 or 4. I think in general, especially for small shops, I think the ideal kind of easiest scenario is you have and kind of an internal registry proxy thing that everyone uses that thing only, and then the vendor that provides that thing also provides assurances that they are free of vulnerabilities and new vulnerabilities are made known to you. I should say though that the GitHub ecosystem is advancing nicely. Dependabot, I think, is a wonderful technology, and even if you take the concept and if a different vendor implemented it, it's just as awesome. Where as new vulnerabilities are found, or even version upgrades from a kind of keeping open source up to date, you just get a pull request. So the pull request does the testing and the validation to make sure that the upgrade doesn't break, and then if you like it, you hit merge, and then you're good to go. Anything that reduces that friction, because you're right. Even if you are if you're a 20 or 30 person shop, you still carry the same level of risk as the largest enterprises in terms of open source is kind of existential to your business, but you can't throw a team of 50 at the problem. So for that, I think the vendors and the automation is absolutely key.
Well, thank you for that. There's a question about roadmap. I just replied to the person that this is a public webinar, so we normally don't share roadmaps, but I did provide a link where they can sign up for the private preview and where the roadmaps can be discussed. But thank you for that feedback from this anonymous person. And we're receiving lots of instant feedbacks. They're liking the session so much, so this is great. And there's a question on will there be a session on the practical defense for open source software in the enterprise? Example, WSL2 that has the firewall bypass and links files back to the OS. I appreciate this session for this fits overall security picture. Anything on that?
I don't. I need to think a little bit about where that would fit in. I think that's super important, especially well, WSL2 is especially interesting because of its ties back to the OS and the fact that most of WSL2 is functionally just open source stuff. But I don't. I think it would make a great session to really talk in detail about that and similar things.
We'll be in touch on that, and we'll see how that goes. Thanks for that. There's a question: will there be a defender for PostgreSQL?
Oh, I don't know. I would. I mean, I would direct that to the defender team. I assume you mean as data is pulled in or out of Postgres, whether having defender scan that like I guess it would SQL Server. That sounds like a reasonable request.
Yeah, perhaps just an extension to that question, and this could more likely come from the same attendee. Is Microsoft going to provide a list that we can search when using the PaaS app SVC for the PostgreSQL, etc.?
Meaning the list of yeah, I'm not sure a list of what. If the question is about the list of open source components that have been integrated into the Postgres as a service thing, you'd have to check with the Postgres as a service team.
Sounds good. Perhaps the person may elaborate here as we tackle the next question. So Steve is asking, is anyone at Microsoft looking at publishing a high assurance ecosystem of OSS packages on a subscription basis?
That is a really good question. So first of all, I'm not aware of anything, and well, I think if I were, I probably wouldn't be able to disclose it. But I'm really not aware of anything like this. In some ways, I would. If someone asked me, "Hey, Mike, what do you think about this?" The caution I would give is, you don't want to bifurcate the open source ecosystem and have the Microsoft open source packages like being a kind of blessed mirror of certain external packages. I would rather put whatever time and effort we would spend in creating such a high assurance ecosystem into making the outside ecosystem more high assurance. But I do think that there is a need for a higher higher assurance on at least certain parts of open source. I would refer you to the Open Source Security Foundation. There is a working group specifically targeting critical open source projects, and there was recently a project that's associated with that called I believe it's pronounced SLSA, SLSA. That just went out maybe yesterday, the day before, talking about the how you gain assurance and how you bucketize different open source components into into basically assurance levels. So you may say that for I'm building this into a into a pacemaker, therefore it needs to be level X, or it's just a calendar widget on my marketing site. Maybe that's a different level.
Well, thank you, Michael, for such a great information. This was a phenomenal presentation, and thanks for the rest of the team who, in fact, helped answering the questions. And just wanted to provide a quick reminder to the folks who are still on the line that the best way to ensure you don't miss any future webinars or major announcements, please visit our landing page at aka.ms security community. And here I'll just paste this. By the way, all the resources that you had on your deck, I have shared here with the team, although the deck will be shared as well post this webinar. And while you're in our landing page, you'll hopefully you'll find it easy to navigate and find the resources and the learning content relevant to our security products and their communities. I suggest a good start would be to just start browsing on a bit-sized product videos that we have, the Ninja trainings, recordings of past webinars, GitHub communities, and I think there's more to it as well. And as far as signing up for our future webinars, as well as locating the recordings, you can always refer to aka.ms/security webinars. I would like to close this webinar by thanking you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.